Hello. Our project is exposing fake COVID-19 news. We're doing this for the class CS4641. While social media enables greater communication, it's also enabled the spread of false and misleading information. This is especially true when it comes to information regarding the COVID-19 pandemic. Our ultimate goal for this project is to create a system that can automatically detect fake news. And in this section of the project, we want to perform initial exploration of our data via unsupervised learning. Some components of this phase of the project include data cleaning, vectorization, dimensionality reduction, clustering, and visualization. For our workflow, we first have to gather our data by downloading our dataset. This is the COVID-19 dataset, which contains tweets from Twitter, and as well as labels that label these tweets as true or false. We then perform data cleaning to delete any irrelevant or corrupted tweets, and then we use an algorithm for vectorization called term frequency inverse document frequency to convert the actual text of those tweets into numerical representations.
All right, so before actually performing the unsupervised learning, we decided to reduce the number of dimensions to further increase the performance of our unsupervised learning algorithm. To do so, we use principal component analysis and reduce the dimensionality from about 1,000 to 100 dimensions. From there, we utilized the k-means algorithm on the dataset and separated the data into varying number of clusters, analyzing the results of each.
After applying k-means to our dataset for between 1 to 41 clusters, we generated a graph of the WCSS values to try to find the optimal number of clusters. Our graph was fairly linear, so applying the elbow method wasn't immediately obvious. We chose to use a low value of 6 clusters and a high value of 30 clusters and evaluate both results. For both numbers of clusters, we generated heat maps using the 25 and 50 highest frequency features to show the correlations between feature frequencies and cluster assignments. With 6 clusters, one cluster dominates somewhat in the grouping of multiple clusters, and the heat map also shows that one cluster in particular is significantly different from the rest. With 30 clusters, the clusters are a bit more spread out and distinct in their grouping. The heat maps also appear to have more separation amongst the clusters.
Our main outcome this phase was the production of vectors from our dataset, which included some data cleaning and feature selection using PCA. We also found success with the k-means algorithm, which will also be useful for the second portion of this project. We can use our implementation to determine which features were best able to predict classification and to see cluster formation between fake and true subcategories. In the unsupervised learning portion, the heat maps we generated helped us understand what features are the most significant in our dataset. In the next phase of our project, we will use heat maps to visualize the distribution of fake versus true news after running the supervised learning algorithms. Looking forward, we plan on training our classifiers using the output of our PCA implementation. Some algorithms that we are currently planning on using are SVM and random forest, and we are also planning on trying out a few more to see what models work well with the parameters of our dataset. Thank you for listening to our midterm report.